Welcome back to the physics class. This is for class 10. This is Ramesh. Okay. In the last two lectures we discussed about what is potential difference and what is the current flowing through the circuit. There are two different concepts we studied. What is electric current and what is the potential difference. If the potential difference is applied, the electric current will be developed. Is there any relationship between current and the potential difference? We and I say yes or no. There is a question mark. Before we are going to find the answer for this, just we do one activity. In this activity, here we are taking four cells which are 1.5 volt each. This is cell number 1, 2, 3, 4. Four cells we are taking. Each cell consists of 1.5 volt. Okay. This four cells arrangement is here. Okay. And we are taking one resistance, ammeter, voltmeter, key. All are taken and they are connected like this. In the circuit diagram, we connected the resistance in parallel with voltmeter. The voltmeter is connected in parallel with resistance and ammeter is connected in series with the circuit. Key, which is used to switch on and off of the electrical circuit, and this arrangement consists of four electrical cells. If four cells are connected together, that is called battery. Okay. But here we are not connected together. First we do one thing. Consider we connect the components of the electric circuit like this arrangement. We connect it. Okay. First we connect only one cell. That means first cell, which is 1.5 volt. This cell only connected inside the circuit. Only one cell is connected to the electrical circuit drawn in the board. Only one cell is connected. Okay. Remaining three cells are disconnected. Only one cell is connected. Consider. At that situation, there is a current passing through the electrical circuit. How much of voltage is given to the electrical circuit, which we take the reading from with the help of voltmeter, because voltmeter is an instrument used to find the potential difference. How much? 1.5 volt. Okay. For example, 1.5 volt is passing through the electrical circuit. How much current is flowing through the electrical circuit? We make some notes. Okay. By understanding this, we can tabulate one tabular column. That means serial number of cells, current, voltage, and voltage by current. The ratio of voltage by current. Okay. First, serial number 1. First we are connected how much cells? Only one cell. So I write here 1. Number of cells connected in the electrical circuit is now 1. Okay. What is the voltage? That means potential difference passing through the electrical circuit, or potential difference between the two ends of the electrical circuit. Here we are using one important. Here we are using what? This is a resistor. Here the wire consists of resistor. Normally the conductor consists of very much less resistance. So here we are using one specialized wire which is alloy. Do you know about alloy? Alloy means nothing but it is a combination of metal and metal. Here two metals are combined. This alloy, the name of this alloy is nichrome. Nichrome is an alloy of two metals, nickel and chromium. Usually nichrome alloy is used for heating purposes. In our water heater, nichrome alloy is used. Why? Because it provides very much high resistance. Okay, so nichrome is an alloy which have high resistance, which is made up of, which is a combined form of two metals, nickel, chromium. Okay. This nichrome alloy is connected here because it have some resistance, much higher resistance when compared to the conductors. So only we prefer nichrome alloy in this place, in this circuit. Okay. Let us consider first the voltage passing through the electrical circuit is 0.4 volt. For example, 0.4 volt is applied between the two ends of the nichrome wire, 2 points of the nichrome wire, X and Y, where X and Y are the two ends of the nichrome wire. we now pass 0.4 volt. How much current is drawn? Now the circuit is closed, only one cell is connected to the circuit. How much electric current is passing through the electric circuit? We can measure the amount of current using this device called ammeter. How much electric current? We say, suppose the current is 0.1 ampere. Okay, good. 0.1 ampere. Okay. Now you are connecting another 1.5 volt or another cell. Okay, we are connecting another cell. Now the voltage is increased. Let us consider now the voltage passing through the circuit is 0.8. Now the number of cells is 2. We can connect one more cell. So the potential difference across the X and Y, the potential difference at the points X and Y across the nichrome wire is increased. How much? In the last case 0.4 volt. Here now 0.8 volt. Now the potential difference is increased. When the potential difference is raised, the current passing through the circuit is also increased. We can measure this current with the help of ammeter. We can measure the potential difference with the help of voltmeter. Okay. So with the help of ammeter, we measure the reading, current reading, which is found to be 0.2 ampere. Wow. By increasing the potential difference, the current also increases. Okay, good. Now we connect another one cell. The third cell is connected in the electrical circuit. That means potential difference is increased. In this case, the potential difference is, the number of cells is 3. The potential difference is 1.2. Now the current passing through the electrical circuit is found by ammeter, which is equal to 0.6 ampere. No, 0.3 ampere. Yeah, 0.3 ampere. Okay. The last cell is now connected in the electrical circuit. The last cell is fourth cell. So number of cells is 4. So the current is 1.6. Yes, 1.6. So this is voltage. 1.6 is the potential difference across nichrome wire. When the cells are included in the circuit, the potential difference increases gradually. When the potential difference increases, the current also increases. Now the current is 0.4 ampere. So what are the observations? What are the inferences we made by this experiment? The first inference is we are increasing the number of cells step by step across the resistance. Okay, we are including the number of cells. When the number of cells is increased, the potential difference is across the wire is increased. When the potential difference across the wire is increased, the current flowing through the circuit is also increased. Okay, when the current flowing through the circuit is also increased, that is the important inference. Okay, what is the another one inference? Another one most important point. The most important point is V by I, the ratio of V by I. What is the value of V? 0.4. The first one. What is the value of V? 0.4. What is the value of I? 0.1. So V by I is equal to 0.4 by 0.1. 4 by 1. That is 4. That is 4. Okay, 4. 0.8 by 0.2. 4. 1.2 by 0.3. 4. 1.6 by 0.4. 4. Yes. So the value of V by I, the ratio of V by I is constant, because when we are increasing the potential difference, the current also gradually increases. Both are increases simultaneously, both are increases with respect to one another. So the V by I ratio will be a constant 1. What is the value of V by I here? The value of V by I is nothing but that is called resistance, the resistance of the conductor. So there is a relationship between potential difference and current. George Simon Ohm is the scientist. He stated a law that is called Ohm's Law. What the Ohm's Law tells about? State Ohm's Law. Ohm's Law states that at a constant temperature, the steady current flowing through the conductor, is directly proportional to the potential difference between the two ends of the conductor. I once again repeat, at a constant temperature, the temperature should be a constant one. Okay, at a constant temperature, a steady current flowing through the circuit is directly proportional to the potential difference between the two ends of the wire. If we increase the potential difference, current also increases. If we decrease the potential difference, current also decreases, but the temperature should be a constant one. If we are changing the temperature, Ohm's law may be invalid, which you will study in the higher classes. Okay, so at a constant temperature, this rule will be obeyed. This is what known as Ohm's law. According to Ohm's law, V is directly proportional to I. Okay, then V is equal to what? V is equal to I into R. What is R? When we are changing the directly proportional sign to equal sign, we are putting a constant. Here, what is the constant? Here, the ratio of V by I is known as constant. That is called resistance. Here, the resistance of the nichrome wire is constant. You are increasing potential difference, okay. So, the current in the circuit increases, okay. Both are directly proportional, yes. But the resistance of the nichrome wire is constant here. So, the ratio V by I, here we can write this as V by I. V is equal to IR. V is equal to IR, so V by I, the ratio of V by I is equal to R. Otherwise, R is equal to V by I, okay. I is equal to what? What is I? I is equal to V by R. So, this is the relationship between V, I and R. V equal to IR, I equal to V by R is equal to V by I. Here R is the resistance, which is the ratio of potential difference and current. Okay. What is the meaning of resistance? Resistance is nothing but it is the property of the conductor or alloy. Okay, which is the property of the conductor or alloy. That means which is used to oppose the charges, the motion of the charges. The motion of the charges produces what? Electricity. If the electrons are moving with a constant velocity, a steady current will be produced. Okay. If we want to reduce the current flowing through the circuit, we may use resistance, because resistor is a device which has the property of resistance. The resistance means opposing the charges. If the charges are moving fastly, when the resistor is connected, the resistor resists the flow of charges, opposes the flow of charges. Due to that opposition, the motion of the charge, the velocity of the charge decreases, so the current passing through the circuit also decreases. So the use of resistor is providing resistance. So what is the use of resistor in the electrical circuits? In the electrical circuits, resistors are used to vary the current. Resistors are used to increase or decrease the current by decreasing or increasing the resistances. That is, the device we are used to vary the current in an electrical circuit is known as rheostat. That we will studied in the last class. Rheostat, you know very well. Rheostat is otherwise known as varying resistance. Rheostat is an instrument used to vary the resistance in an electrical circuit in order to vary the current. If you want to increase the current, you decrease the resistance. If you want to decrease the current, increase the resistance by the help of rheostat, because rheostat is a device which is able to change the resistance. Okay, so this is the importance of the rheostat resistance. Okay, so R is equal to V by I. What is the unit of R? The next is, what is the unit of R? The unit of R is what? What is the law I told now? I stated one law. The name of the law is Ohm's Law. that ohm is the unit of resistance, which is a Greek alphabet. Okay, Greek alphabet. Ohm is the unit of resistance. What is the unit of potential difference? Potential difference unit is volt. Current unit is ampere. So 1 ohm is equal to 1 volt by 1 ampere. When the potential difference across the two ends of the wire is 1 volt, then the current passing through the wire is 1 ampere, then the resistance of the wire is said to be 1 ohm. So if 1 volt of potential difference is applied across two ends of the wire, then the current carrying wire is 1 ampere, then the resistance present in that wire is 1 ohm. That is the definition of 1 ohm. So in this way we can calculate resistance. So from this Ohm's law, we are obtaining the knowledge about the relationship between potential difference and current. The unit of potential difference is volt, the unit of current is ampere. Here I noted current ampere, potential difference volt, V by I is volt per ampere. By using the graph also, we can measure resistance by using the graph also. How? By plotting a graph, by taking current in the x-axis and the potential difference in the y-axis. The unit of current is ampere, the unit of potential difference is volt. We are gradually increasing the potential difference 0.54, 0.8, 1.2, 1.6, 2.0. By gradually increasing the potential difference, the current also increases. Both are increasing gradually. Here current increases with respect to potential difference. Current and the potential difference are directly proportional. So the graph drawn, what is the value of V by I here? 0.1, 0.4. 0.1 is current, 0.4 is what? Potential difference. Next point 0.2, 0.8. 0.2, 0.8. The next point 0.3, 1.2. 0.3, 1.2. Next 0.4, 1.6. The last one is another one reading extra. I noted it 0.5, 2. So all these points are plotted or noted in the graph, and we join these points that makes a perfect straight line. The graph between voltage and current at a constant temperature is a straight line. So this proves at a constant temperature potential difference is directly proportional to current. If there is any fluctuation, it will not be a straight line. Then voltage and current are not directly proportional exactly. But here it is an exact straight line. The graph shows it is an exact straight line. This exact straight line shows what? The current and the potential difference are directly proportional at a constant temperature. That is Ohm's law. Ohm's law is one of the most important law because you will study in the 12th standard also. Ohm's law you will going to study in the 12th standard also. So please remember, this Ohm's law is one of the most important law. It is very easy to understand. Okay, from this graph we learned what? V is directly proportional to I at a constant temperature. That is one point. One more point. If you are taking the slope means what? Y by x. This, for example, this we are taking the slope. This we are taking the slope. This is y-axis. This is x-axis. What is y-axis? V. Y-axis we are taking V. X-axis we are taking I. V by I. So in this y-axis, what are the 2 points here? What are the 2 points? 1.2 minus 0.2. In the y-axis, 1.2 minus 0.8. In the x-axis, it will be 0.3 minus 0.1. The difference is. So 1.2 minus 0.8. What is? 0.4 by 0.1. So that is 4. Which is what? Which is resistance. R is equal to Y by X. Thus resistance is equal to 4 ohm. So the resistance of the given nichrome wire in this case is 4 ohm. We agree that the resistance of the given nichrome wire is 4 ohm. We are calculating by which method? By Ohm's law, by applying Ohm's law. By the graphical method also the same answer will be repeated. How? We are taking the slope. Slope means y by x. So y axis by x axis 0.4 by 0.1, that is 4 ohm. Okay, in this way. So resistance of the conductor or alloy is calculated by the help of Ohm's law. Okay. The rheostat, another one point I want to tell you. Rheostat is an instrument used to vary resistance in order to vary the current without changing the input voltage source. There is one question arises here. If I reduce the cells, number of cells, the voltage source reduces. So when the voltage reduces, the current reduces. Okay, this we know. Without changing the voltage sources, without touching the voltage sources, you need not to change the voltage source, but you want to decrease the current flowing through the circuit. For example, you may use of rheostat, because rheostat is an instrument used to vary, increase or decrease the current passing through an electrical circuit without changing the voltage source. That is one of the most important points. Okay, in this class, my dear students, I hope you very well understood about the Ohm's law, the relationship between current and the potential difference and the resistance. Okay, I am very happy. I think you are also happy. Okay, in the next class we are going with the resistance, another topic, resistance. Okay, till that, bye my friends, bye, thank you.